would you like to kick us off?
Yes. All right. Let me also add my welcome to our webinar today, which will focus on the treatment of carbon removal in the IPCC's new 1.5 degrees special report. My name is Will Burns, and I serve as co-director of the Institute for Carbon Removal Law and Policy, which is a scholarly initiative of the School of International Service at American University that focuses on social science aspects of potential research and development and deployment of carbon removal options in the axes of law and politics and ethics. And at the outset, I'd like to introduce the other speakers for the event today. First of all, Katherine Mach, who serves as a senior research scientist in the Department of Earth System Science at Stanford University. Second, Cynthia Scharf, who serves as a senior strategy director for the Carnegie Climate Geoengineering Governance Initiative. And finally, David Morrow, who serves as director of research for the Institute for Carbon Removal Law and Policy. And they will all be part of the presentations, which I'll outline below. And at this point, I'd like to turn this over to Maya Breitberg-Smith with Resolve, who is helping us host this event today and will discuss the logistics of the webinar. Maya?
Hey, thanks, Will. Welcome, everyone. Thank you very much for joining our webinar today. Just a few kind of logistical notes about how we're organizing the webinar. We will have, as Will mentioned, a series of presentations where we hear from the speakers, and then we will have a chance after their remarks for some questions and answers. So throughout the webinar, I encourage you to use the chat pod in Adobe Connect, which is at the bottom right of your screen, the area that says Presenter Chat, to type in your questions that you might have for the speakers. We'll then, during that question and answer period that's scheduled to start around 12:35 Eastern Time, U.S., we will have a chance to look at those questions and answer as many of them as we can in the time that's allowed. We will also be recording the webinar, so just to let you know that we will be recording and sharing a recording of this webinar after it concludes. And just a little bit about Resolve. Resolve is a mediation facilitation organization started about 40 years ago as a conflict resolution organization based in Washington, D.C. We work on environmental and public health issues, and we now, in addition to kind of doing that traditional conflict resolution today, we also convene dialogues, identify issues that really could use people collaborating, some collaboration, and help people move forward on some sticky issues. So we're really happy to be working with Will and the Institute on organizing this webinar today. Thanks.
Thank you very much, Maya. And at this point, I would like to invite Katherine Mach to make her presentation, which will focus on the question of what does the 1.5 C report say about the potential need for carbon removal. Katherine?
Thank you so much, Will, and it's really great to have the opportunity to talk with all of you. So I'll be addressing the three questions that I think you can see there on the screen of what are some of the broad themes about how carbon removal is addressed in the new report from the Intergovernmental Panel on Climate Change. But to frame these two questions, I'd like to emphasize just two broad themes first that are really critical for understanding what this report represents and how to understand the role of carbon removal within it. So first of all, why are we talking about 1.5 degrees Celsius? It's a surprisingly confusing notion in the science policy landscape, and so I would like to start there. And in many ways, the reason why we're talking about 1.5 degrees Celsius is because climate change is here and now. This report, as is the case for the report that came before it, the IPCC AR5 really underscores that the impacts of climate change are widespread and consequential now on every single continent, and that's something that we are increasingly dialing in event by event, not just in broad trend. So then if we think about the broad trajectory of climate change assessment, historically, the first emphasis was thinking about, well, what might the impacts be if we just go ahead business as usual and let warming climb to potentially 4 degrees Celsius? Then, several decades ago, increasingly attention focused to a world of really ambitious mitigation, maybe a 2 degrees Celsius world. But as we step forward to our current moment, both in terms of science and in terms of how policy, whether it's the Paris Agreement or city-scale action and society has evolved more broadly, we're increasingly recognizing that we need to respond in real time to impacts that are happening. Those impacts go up in a 1.5 degrees Celsius world, and they go up even further in a 2 degrees Celsius world and beyond. And those impacts pertain to extremes, to the most vulnerable systems, whether it's coral reefs, small islands, or to some of the game changers, the potential for tipping points, sea level rise, ice sheet loss. So that's number one. We really need to dial in attention to 1.5 degrees Celsius because it carries real impacts. The second framing theme that is through this report, chapter by chapter, is that ambitious climate responses really require an all-of-the-above approach. That's about preparing for the impacts that are happening now in our energy sector, our water sector, our ecosystems for food, agriculture, etc. But it's also about mitigation that tackles everything. Emissions from our energy systems, transportation, buildings, land, and agriculture. And carbon removal, as the report underscores, plays a really important part of that all-of-the-above action in an ambitious climate response. So what is carbon removal for the purposes of this report? There are two important entry points on this question. What is carbon removal? First, the report does a lot of assessment of the full landscape of carbon removal. You can think of carbon removal as being the suite of options, technologies, approaches available for removing carbon dioxide from the atmosphere. On one end of that spectrum, the mode of getting carbon dioxide out of the atmosphere is photosynthesis, tried and true method here on planet Earth, where plants in growing use CO2 through the process of photosynthesis to make the mass of the plant biomass and can store that carbon on the landscape, in the oceans, in the soils. So there are many approaches the report introduces that really just start and end there with biology, whether it's how we manage our lands or restore our soils or plant new trees. Through to the other side of the carbon removal spectrum, the report also introduces approaches that are fully engineered, whether that's using sorbents or solvents to pull CO2 out of the atmosphere and then inject it deep underground into geologic storage, or whether it's things like enhanced weathering that are more tapping different chemical processes. And in the middle of that spectrum, there are approaches that are biologically based, but with more engineering. In particular, bioenergy with carbon capture and storage, where you grow bioenergy crops. That is the process that removes CO2 from the atmosphere. You then use those crops to generate fuels or electricity, capture the CO2, and send it down underground into geologic storage. So the report really emphasizes that there are a large number of approaches for removing CO2 from the atmosphere. But an important note is that when it models pathways of how we might limit warming to 1.5 degrees Celsius or less, with just a tiny bit of overshoot or with no overshoot at all, it uses two approaches most of all: afforestation, or planting trees at large scale of the surface of the earth, as well as bioenergy with carbon capture and storage. So that brings me to the second question here of how does carbon removal factor into what it takes to stay below 1.5 degrees Celsius warming. The report sets the bounds to think about how important carbon removal is in two basic ways. So number one, it starts with the geophysics of how our climate and planet work. And in particular, there's the fact that when we put CO2 into the atmosphere, it has near permanent warming. Other gases have shorter-lived warming, but that long-lived forcing from CO2 can be a really simple way to think about our climate challenge as one of setting a budget that remains for any warming goal we have and then keeping remaining emissions within that budget. So we've put over 2 trillion tons of CO2 in the atmosphere to date since pre-industrial times. And there are a lot of different ways to look at the remaining budget. Uncertainties come into focus when we're dwindling down to the last billion tons of a budget. For example, how much more CO2 might be released from permafrost, what kind of probabilities are we setting, what temperature do we want to look at historically. But you can think about the remaining budget as being around 600 billion tons of CO2 for a decent chance of limiting warming below 1.5 degrees Celsius. So in that type of very constrained budget, where we're putting 40 billions of tons of CO2 into the atmosphere each year, and we're talking 10 or 20 plus more years until we may very well reach 1.5 degrees Celsius warming, carbon removal comes into focus in 2 ways. First, at any one moment in time, it can help us decarbonize our full energy and land systems by offsetting some of the hardest to reduce emissions, whether those are emissions from agriculture or from long-distance shipping or from steel and cement. So at any one moment in time, carbon removal is important. But carbon removal also can play an important role through time. For example, shaving the peak off of how much warming that happens, or once we enter into a state where we have stabilized the climate and our emissions are at net zero, further deployments of carbon removal can help draw down CO2 further and lead to a decline in temperatures. I'll just close with a few reflections on how these findings are derived. So the Intergovernmental Panel on Climate Change is a really unique entity in the science policy landscape. There really isn't anything else like it. In some ways, you can think of it as a grand partnership between the governments of the world and the scientists of the world, where the governments essentially say, scientists, if you follow our rules for developing a comprehensive assessment of what is known right now, we will use that assessment as the basis for what's known about the changing climate, its impacts, its risks, and how we can respond. So the mandate is to be comprehensive, to consider all relevant evidence, and a key way that that comprehensiveness is achieved is through multiple rounds of monitored scientific review, where anyone in the world can sign up to provide comments that the authors have to consider and respond to in writing. In terms of the specific evidence basis on carbon removal, there are many different independent lines. Some of the evaluations are top-down, whether it's the geophysics that I mentioned or the modeling that I mentioned that's about creating pathways, trajectories, cost-effective ways to achieve given mitigation targets. But we also see a lot of bottom-up evidence going sector by sector through different approaches and saying, what would it take if we think about cement and iron and steel, hard to decarbonize industrial sectors, or whether we think about agriculture, what might the role of carbon removal be in terms of becoming integrated in our full responses or helping offset emissions in space or in time. So thank you, Will, and I'll now turn it back to you.
Great. Thank you so much for that overview, Katherine. Now, I've been tasked to very briefly talk about the discussion in the report of risks and challenges associated with potential deployment of these technologies, and I'll do that for about 5 minutes. So as Katherine had indicated, the report privileges 2 carbon dioxide removal options based on what the integrated assessment models in the 5th assessment report have done and kind of the proliferation of projects and literature since then. And that's afforestation and bioenergy and carbon capture with storage. And the lion's share of the assessment of potential risks and challenges associated with these approaches parallels that in the report, primarily in Chapter 4. In terms of bioenergy and carbon capture and storage, which was the predominant, one of the 2 predominant forms of technologies that were looked at in integrated assessment models in the 5th assessment report to hold temperatures below 2 degrees Celsius. The 1.5 report talks about a number of potential risks associated with large-scale deployment of Becks. It indicates that the average amount of Becks in the relevant concentration pathways that were discussed in the report would require somewhere between 25 to 46% of arable and permanent crop area in 2100, which is certainly a sobering requirement. It indicates that some of this could be obtained through things such as crop residues, for example, and forest residues. But in other parts of the report, it indicates that there's necessarily trade-offs in that context. For example, if you're diverting crop residues to utilize in the Becks process, you may be decreasing nutrient supplies for crops, which means you may have to expand crop areas or you may have to reduce food security. And so those trade-offs would necessarily have to be assessed, and they're acknowledged to some degree in the report. In terms of afforestation, it's noted that in pathways that allow for large-scale afforestation in addition to Becks, the land demand for afforestation can be even larger than Becks. And so some of the same issues that are associated with that, which include potential impacts on food security, impacts on livelihoods for those that utilize these lands, either for forests or other purposes, biodiversity impacts could all be impacted in this context, as well as things such as water demand and the need for fertilizer and the impacts in terms of the nitrogen cycle, all of which are briefly discussed in the report. And then overall, it concludes that a pathway that shows a coupling of Becks and afforestation measures to hold temperatures to below 1.5 C could require, quote, up to the magnitude of current global cropland area. And so we're talking about very large potential impacts in terms of diversion of croplands as well as other areas. The report is more skeletal when it talks about potential risks and challenges associated with other carbon removal technologies. The discussion in direct air capture is surprisingly short. Talks a bit about energy requirements, talks about requirements for storage of carbon dioxide, potential leakage issues, but again, not in any great detail. In terms of some of the other options, it talks briefly about the potential health implications associated with enhanced mineral weathering in terms of potential releases of toxic heavy metals into the atmosphere and into water bodies. In terms of ocean-based options, the focus is on two. One is ocean alkalization, efforts to a method that's also called ocean liming. It talks about potentially changing biogeochemical cycles and potential ecosystem impacts associated with that, as well as potential releases of heavy metals associated with enhanced mineral weathering done in an ocean context. But in all of those cases, the risks are looked at with a lot less detail and perhaps not as comprehensively. Some of the risks associated with enhanced mineral weathering, for example, such as mining risks and some of the social implications that might be associated with that, are given short shrift to some degree, mainly because the literature is a bit sparser and more speculative at this context at this time, and also perhaps because the focus again is on what has been assessed to a greater degree to date. But again, if we are to pursue a portfolio approach, as is advocated in the report, the assessment of these would necessarily have to increase. And with that, I will stop this portion, and we will now move on to a discussion of the treatment of governance issues in the report. And I'll turn it over to Cynthia Scharf at this point.
Great. Thank you, Will. I have put together a few slides. I promise I won't bore you with text-heavy slides here. Just wanted to identify a few key issues. that have emerged in the report, primarily in the underlying chapter, chapter 4. All right. So let me skip this terminology here. What does the IPCC have to say about the definition of governance? It's a very inclusive definition. It talks about governance being a process of interaction.
Sorry, Cynthia, I think some of the participants are having a little bit of trouble hearing you. I'm wondering if you could get a little bit closer to your phone.
Sure.
And also I'm hearing just a little bit of feedback, so just a reminder to the other speakers that if you are not speaking, to please mute your phone using the mute button on your phone or a *6 to mute your phone. Thanks.
Sure, no problem. Is that better?
Yes, thank you.
Okay, great. So let me start with what the definition of governance is in the IPCC report. It's defined in a very broad sense as a process or processes of interaction and decision-making among actors that are involved in a common problem. And this notion goes beyond formal government or formal political authority and integrates other actors, informal institutions, and communities into that definition. So it's very much an inclusive concept of governance. It recognizes contributions at various levels, from the global to the local, and that includes regional actors, subnational actors, and local communities. It also talks about the contributing role to governance that the private sector can play, that non-governmental actors and civil society can also contribute into the process of creating governance. There's here 7 different types of governance that are described. I'm not going to go into these, but just to show that the authors of this report really did think of governance in a broad, integrative sense. So what are some of the key findings? Here, if we look in Chapter 3 on the underlying, in the summary for policymakers, the report is very cognizant of the fact that these large-scale usage of carbon dioxide removal technologies will potentially entail serious trade-offs. And so there is discussion of governance that would be needed for the significant impacts on land, energy, water, nutrients that might occur if CDR is deployed at a large scale. And governance here is cited as a need to limit some of these trade-offs and ensure the permanence of carbon removal. And this is in particular cited in some of the agriculture, forestry, and land use CDR measures that are discussed. Because again, at large scale, there's a recognition that there could be potential trade-offs and competition for key resources. In Chapter 4 of the underlying report that informs the summary for policymakers, there's also some discussion about what are some of the cross-cutting governance issues. And here there's an acknowledgement that we really have a scarcity of overarching cross-cutting governance at the present time. And what we do have is targeted at particular options or aspects. So for example, on bioenergy carbon capture and storage, or Becks as the acronym is known, it cites that Becks deployment pathways have inadequate assumptions built into them on how governance would be would help regulate and protect societal interests and preserve a sense of integrity and well-being within communities. Some of the other cross-cutting governance issues, the governance for that really only exists at national or regional scale, and there is a paucity of international governance on these cross-cutting issues. One of the only international governance mechanisms that is currently in place is for the research and development of ocean fertilization, and this is embedded within the Convention on Biological Diversity. The report also notes that some authors are stressing the importance of a human rights-based approach to protect those who are potentially adversely affected by the deployment of large-scale CDR. And then finally, the report answers a very basic question. Why is international governance necessary? What are some of the potential benefits? And specifically on CDR, these include having a voice in diplomacy on this issue and the benefits from research collaboration that could be governed at an international level. So with that, I will turn over now to Will, who might have some additional comments he wants to make on the governance issue.
Great. Thank you very much, Cynthia. That was pretty comprehensive. I'll just add a couple of remarks so that we can get quickly to questions from the participants, of which there are a lot. A couple of other things about governance that leapt out at me is there was substantial emphasis more broadly in talking about climate change measures for a role of public participation and deliberation. And I think that could be critical in this context. There's been a fairly extensive discussion about what would be needed in the context of solar radiation management geoengineering, which is often coupled with carbon dioxide removal discussions, but less so in terms of CDR. And if we're talking about options that potentially involve storing huge amounts of carbon dioxide under people's land, if we're talking about options that might have impacts on food security or on livelihoods or water or biodiversity, a public role in determining at what scale we might wish to do this and how we ameliorate any potential adverse impacts would seem to be critical. And the report acknowledges that, though does not go into great detail in terms of how we might facilitate this. Another interesting aspect, again, not in the context specifically of geoengineering, but the broader discussion, the extensive discussion in the report on governance considerations in terms of meeting the 1.5C objective is the need for polycentricity in governance, the need to coordinate various regimes that might govern different aspects of climate responses. And I think that would apply in the context of many of these carbon dioxide removal approaches. If you look at ocean carbon dioxide removal options, for example, it might require coordination not internally in terms of the Paris Agreement and the Framework Convention, but also with regimes that regulate the oceans. Not only the London Convention, which is talked about in the report, but also the Law of the Sea Convention, the United Nations Fish Stocks Agreement, regional pollution regimes, all might have a role, and there'd be imposing challenges in coordinating their roles within the climate regime or independently, and that's given some short shrift. Similarly, if we're talking about things such as enhanced mineral weathering, for example, there could be transboundary impacts in some cases in terms of the release of silicates and other materials that might be associated with these processes, and that again would require coordination both bilaterally and perhaps in terms of international regimes that address those kind of pollution issues. There's also a discussion of the need for monitoring, reporting, and reviewing institutions more broadly in the context of climate change. And again, a lot of those regimes and establishing those regimes would be critical for protecting us from some of the challenges or the risks associated with these technologies, as well as providing more legitimacy if we deploy them. And then the last thing I'd say is that there's a lot of discussion about how governance might facilitate development of new technologies, including the role of government in research and development, and that's talked about more broadly in terms of climate technologies in general, but a lot of what they're talking about, including government research and development as well as potential pricing mechanisms, would be important also in this context. And with that, I'll turn it over to Maya to field some of the questions from the participants.
Thanks, Will. I think we actually have time for some comments from David Morrow, and then we'll turn to the questions.
I'm sorry.
David,
I'm very sorry, David.
Thanks, Maya. I just wanted to say a few words about the way that the special report classifies carbon removal, because it represents a departure from past IPCC reports. So here's the short version of the story. The authors of the special report had explicitly classified carbon removal as a kind of mitigation. And that was a departure from past reports. But this explicit classification was rejected during the governmental review of the summary for policymakers a couple of weeks ago. To explain in more detail and put this in context, let me back up a bit. In the fifth assessment report, 2013 and 2014, the IPCC says that the boundary between carbon removal and mitigation isn't clear, and that, quote, there could be some overlap between the two, given the current definitions. And that fit right in with the way a lot of people, at least, were thinking about carbon removal and mitigation at the time. But in writing 1.5 report, the authors explicitly said that carbon removal was a type of mitigation. So you can go to the IPCC website right now and download the draft of Chapter 1 and the glossary for the report, and you will find in those drafts explicit statements that carbon removal is a type of mitigation. At some point in the process of finalizing the summary for policymakers, something prompted governments to strike any explicit characterization of carbon removal as a kind of mitigation. I have yet to find a report of exactly what led to that decision, but the IPCC has published a document on the special report website that summarizes trickle-back changes to the report, which are changes that will be made to the report text to make it consistent with the finalized summary for policymakers. And that document instructs the IPCC to edit the section on carbon removal so that it, quote, does not imply explicitly that carbon dioxide removal is considered a form of mitigation. That document also instructs the IPCC to edit the glossary, striking lines in the definitions of carbon removal and mitigation that explicitly link the two. But that trickle-back document doesn't require the IPCC to say that carbon removal is not mitigation. What does that mean for the report? It's a little unclear. We'll have to see how the report, the final version of those chapters shakes out. My guess is that the report will just remain silent on whether carbon removal is mitigation. So then let me turn quickly to the way the connection between carbon removal and geoengineering. In the fifth assessment report, the IPCC had said that some kinds of carbon removal would count as geoengineering. But in the 1.5 report, the IPCC explicitly abandons the term geoengineering, saying that the literature uses the term ambiguously, sometimes including only solar geoengineering or solar radiation management, sometimes including carbon removal. And so they just don't use the category anymore, treating carbon removal and solar geoengineering as completely distinct kinds of responses to climate change. Given the situation at the moment, it's a little unclear what this means for carbon removal going forward, but it seems likely that it will remain in limbo. And I would add as a final remark that I don't think this is just a terminological dispute. It bears directly on political and policy and legal questions. For instance, what kinds of carbon removal could be counted in a country's nationally determined contributions for Paris, and how carbon removal would fit into national and subnational mitigation policy. So thank you all very much for your attention, and I think that brings us to time for questions.
Great, thank you so much, David, and to all of the speakers. So for the question and answer section of this webinar, we'll start. I think there are some questions that were asked earlier on that perhaps were already addressed in the comments. So we'll come to those towards the end and start with some of the questions and try to group some of the questions that are similar so we can talk about some themes. So I will go ahead and read out the question. that someone has submitted through the chat box, and then turn to the presenters to see who might be able to speak to that. So the first question is about the technology related to CCS, or carbon capture and storage, and the person asked that the technology is related to CCS is very similar to the technology for fracking. What kind of legal framework might be necessary to prevent CCS from being used to extract fossil fuels?
I guess I'll take a first stab at that. That's an ongoing issue and controversy. I don't believe it's discussed in this report, but there are many people who advocate using enhanced oil recovery, a method that would increase the amount of oil that could be removed from the ground, utilizing carbon injection as a way of helping to pay for the CCS process, absent a price of carbon. And so that obviously sparks controversy among those who believe that gives an enhanced life to the fossil fuel industry, while others argue that it would displace oil demand from other areas, and at the same time you will get the benefits in terms of storing substantial amounts of the carbon. But there certainly is some discussion of utilizing CCS and enhanced oil recovery as a way to help pay for it.
And this is Katherine. Maybe just one other point is I think there is also a question of what is socially and institutionally acceptable and feasible as compared to the technical potential for CCS. So for example, in the space of the technical potential for CCS, the report in some of the scenarios pushes up towards 2,000 billion tons of CO2 injected underground over the course of the century, not just for Becks, but also on fossil. Those are huge numbers, and we certainly don't have the governance framework for those types of numbers or even major open questions around social acceptability. At the same time that at the near-term entry point, we can build much more strongly from existing institutions that exist, for example, here in the US with EPA classification of wells.
Thanks. So a few others, the commenters asked about Becks. One person asked, they said, Becks, etc., diverts our attention from the need for societal change and emissions reductions. Please comment. A different question, but also related to Becks, someone asked, can someone speak to how Becks has evolved over previous reports? For example, is the current report the first instance in which Becks has been privileged as one of the top 2 removal strategies?
There's
the one about kind of, go ahead.
Do you want us to jump in already?
Yes, please.
Great. Maybe I'll just raise 2 points. There's a huge amount that could be discussed here. I think many people on the call and all of the participants, just looking through all the names there, very clearly understand that Becks can't be a decoy for steaming ahead on oil and gas. This is really a question of deploying all technologies to decarbonize our energy, land, and industrial systems and adapt for the impacts that are still in the pipeline. I think a helpful analog is to jump back multiple decades ago, back when the IPCC was just in its first decade of existence. At that point, there is huge tension around mentioning the word adaptation, that we might need to prepare for impacts that would materialize and in our current world that are materializing. So this is not a question of do we draw down CO2 through deliberate approaches or do we directly address other emissions from our energy sector. It really is a yes and type of approach. Then on the question of the Becks evolution, it's a pretty nuanced feature. In terms of where Becks shot onto the scene in IPCC assessment, it really was the 5th assessment report, which came out in 2014. In those assessments, in that case, really around 2 degrees Celsius pathways generated by integrated assessment models, Becks was deployed at very large scale, 10 to 15 billion tons of removal per year at the end of the century, for example. What we see in terms of the scenario set put together for this report, which again is an ensemble of opportunity, basically looking at all of the model runs that have been done over the last few years, is that there is increased emphasis on getting the tough parts of the land sector right in terms of transformation rates. There's been development of many of the models in that space. Again, there's a look at agriculture, forestry, and land use in an integrated sense where it is indeed reducing deforestation at the same time that it's planting trees. And there are just some new models that are starting to bring on other methods of carbon dioxide removal, for example, management of soils or direct air capture. So on the Becks evolution, there's continuity at the same time that there's some new features.
Now, one thing that I'd briefly add is that one of the things that the report emphasizes is that if you don't aggressively seek to reduce greenhouse gas emissions and you're going to hold temperatures to below 1.5 or even 2, it almost necessarily requires you to massively escalate your use of things like Becks, and that's when sustainability considerations really come to the fore. If you can aggressively mitigate, the report indicates that you may be able to hold use of these technologies to a relatively low level, such as 100 to 200 gigatons over the course of the century. If you don't, you have to go way up. And then all of these associated potential risks with land and water and biodiversity really start to come to the fore. And so it signals to society that this necessarily has to be a supplementary tool, and that society has to not weaken its resolve because there's huge trade-offs.
Mm-hmm. Thank you. I think these next two questions are somewhat related to our last conversation, so I'm going to go ahead and group them together as well. One from Jeremy on deforestation and afforestation. He asks, shouldn't deforestation be slowed or stopped before discussing afforestation as carbon storage? It's a much more immediate method to reduce emissions. Land requirements for afforestation are massive, and frankly, its benefits won't be realized for a long time. Providing immediate benefits, avoided deforestation also has the added benefit of potentially providing immediate benefits to local communities who are the stewards of their forests and ultimately control its fate. Another question from Bruce, he asks, why is there so little attention to avoided deforestation and soil carbon sequestration? Afforestation emphasis seems so limited.
I'd be happy to answer those questions from the modeling perspective, although there's much to be said beyond that. So it is indeed the case that the high-level top-down modeling groups in its reporting of results a lot of the different emissions from the land sector. Agriculture, forestry, land use, that indeed involves emissions from deforestation as well as agriculture more broadly. Even in that case, in many of the scenarios, those emissions from deforestation are wiped out within a decade or two. So there's, to achieve 1.5 degrees Celsius, it requires essentially tackling all parts of where emissions are coming from in the world right now and driving them to zero by the middle of the century and reducing the short-lived forcers like methane to very small and stable levels. I think the other feature is that it's really important to recognize that the top-down big picture modeling is important for understanding broad features of the challenge of responding to the climate issue. But as Cynthia really emphasized, many of the governance questions are all about the intersection of local level action, community action, subnational action, private sector action, as well as these essentially economic and energy system thought experiments at the global scale. So it's really critical to recognize that even though the models mostly look at Becks and they mostly look at afforestation, those are some of the stand-ins for tackling all of the different emissions associated with the land together.
Yeah. And I just add that there is a fairly extensive discussion about the prospects for soil carbon sequestration, and I think they estimate that it could have a substantial role, somewhere between 2 to 5 gigatons a year. with negligible water and energy requirements and co-benefits, though there's cautions about the saturation points for soil sinks, which can be substantially short in some cases. But I think it's a very good point. It's definitely one of the options that probably deserves more discussion than was devoted to it in the study.
Mm-hmm. Okay. Thanks. So another question that we got from Jose is about defining carbon removal as mitigation. Jose asks, what are the legal and political consequences of defining carbon removal as mitigation? And David, perhaps this builds on your remarks.
Sure. So one thing that would matter if you do define carbon removal as mitigation is that it means that funding for mitigation or policies aimed at promoting mitigation could be tapped for carbon removal purposes, which will please some people and not please others. It would also make clear that if that definition were taken up within the Framework Convention on Climate Change and the Paris Agreement, then it would make clear that parties could include carbon removal as part of their nationally determined contributions. If you don't define carbon removal as mitigation, as if the report or whatever legal regime you are interested in is silent on the matter, then I think it's a little unclear about whether you could use programs or policies or funding aimed at mitigation for these purposes. If you explicitly exclude it, then all of those resources would not be eligible for use for carbon removal, but at least the way things have been for some time is that certain kinds of approaches, like afforestation and soil carbon sequestration, have been treated as forms of mitigation. And so if an attempt to exclude carbon removal from mitigation would probably amount to saying, well, carbon removal is not the right term here. There are some kinds of approaches or technologies that remove carbon from the atmosphere that count as mitigation, and there are some that do not. That is, if you wanted to exclude carbon removal from mitigation more broadly. Does anyone else want to add anything to that?
Sure. This is Cynthia. I just wanted to jump in on this and to say, as I think Katherine mentioned earlier, removing CO2 from the atmosphere is certainly not a new idea, and the UNFCCC has always considered mitigation to include both emission reductions and removals. But what is new now is the scale of those removals, the nature of some of those measures and approaches, and the urgency with which CDR is now being considered. And put all those together, and the question is, what does that mean for effective governance? Is the structure under the UNFCCC currently sufficient to cover the broad range of issues that massive use of CDR might entail? So everything from trade-offs with land and water to transboundary rights on storage or leakage or liability thereof. So it's both a continuation of what we've already seen in the UNFCCC framework, but now given the scale and the different types of technologies that are being discussed, there could be new issues that arise. We're currently undertaking a study to look at some of those to see if, in fact, there are governance gaps. So we don't have an answer for that yet, but we're simply raising the question. Might there be governance gaps that need to be addressed given the scale and the new types of CDR that are being discussed at the moment?
Yeah, I'd say very quickly, one of those issues that exist is Jan Minks, who's written on these issues, has argued that the references to sinks in the standard definitions of mitigation under the Framework Convention or the IPCC to date talk about enhancement of sinks, which implies that there's sinks that already exist. And so things such as enhanced mineral weathering, oceanary fertilization would necessarily fit into that. But he argues that Becks might not, because it doesn't enhance existing sinks and seeks to induce new ones. And so there could be some potential gaps or needs to expand the ambit of how that term is defined by the institutions.
If I can add one more quick thing, I think one of the concerns is not so much a legal one as, I guess, a social one, that if you define carbon removal as a kind of mitigation, some people worry, you will invite people to think that we can just substitute carbon removal for emissions reductions, and that this would be an authorization for continued greenhouse gas emissions. And as Katherine emphasized earlier, that's not the case, right? We can't do carbon removal instead of emissions reductions. It's got to be a supplement, as Will said. And so the worry about defining carbon removal as a kind of mitigation from a social perspective is that people will lose sight of that need for emissions reductions.
Thanks. This next question is for Katherine from Mike. Mike asks about, he has a question about the notion that the tipping point for sea level is somewhere above 2 degrees Celsius seems quite implausible given how the ice sheets are responding, and suggests that it might be closer to 0. And so Mike asks, to what extent can CDR be ramped up to be used to get to very, to what degree can carbon dioxide removal be ramped up to be used to get to very low temperature increase? So kind of he asks, what are the upper limits of CDR?
Great question, and thank you, Mike, for that. I know Mike is aware that sea level rise is undergoing a really fabulous assessment as part of the Oceans and Cryosphere report. So in some ways, what's in this 1.5 degrees Celsius report is just a brief introduction into that big realm. It is indeed the case that the questions around the irreversibilities of ice sheet collapse, where we first want to look at the West Antarctic and then Greenland and then even the East Antarctic, are critically important in terms of committed climate change from even 1.5 degrees Celsius warming. And this report underscores that there's an important increase in risk as you're going from 1.5 to 2, or even questions as to whether irreversibilities have already been traversed in parts of the West Antarctic. And that is something that what I've seen from the draft chapters of the sea level rise assessment is very well discussed there, and will certainly be an increasing move going forward. I think this broader point here is that the geophysics of carbon removal in some ways have been much less studied to date because all of the climate models have been run with the emissions going up, whether it's the SRES scenarios or then the RCPs with starting to bring them back down. But the question of whether it's the permafrost or the ice sheets or other features of what it means to have emissions drawing back down, really critical questions. And I think as Michael Oppenheimer in his assessment in the AR5 and continuing into the special report has underscored, those are some of the unconstrained uncertainties in the space of the ice sheets in terms of we know what happens if you hold temperature at 2 degrees Celsius for many millennia. We really don't know what happens if you blip it up for a few decades and bring it back down.
Mm-hmm. Thanks. Mike did just type a follow-up question in the chat pod, and I invite the presenters to type some responses into that chat pod in response to his additional question as you're able. There are a few questions that we got around specific technologies. So I might ask some of these together as a group as possible so that we can efficiently move through some of the remaining questions. So Daniel asked about artificial trees for carbon sequestration and asked if there could be any clarification about the strengths or drawbacks related to this technology, and especially how does that compare with afforestation or reforestation. Similarly, Zachary Perry asked, do the speakers feel that carbon capture and utilization, for example, creation, chemical feedstocks or creation of carbon fiber have a potential to impact climate change? Yeah, so those two seem to be about kind of using carbon to, or kind of artificial technologies to store carbon.
Can give the exceedingly brief response, recognizing that this could be an hour-long discussion. All of the different methods and specific technologies around carbon removal are very actively being innovated, developed, deployed, and pursuing the questions around when they might scale and how fast, and as Mike just emphasized, when we will have the governance to handle them. Certainly things like utilization are very prevalent on that theme. I think what I've heard from many of the researchers in that area is that at the same time that there are real opportunities, you need to be attentive of the maximum potential scale, and utilization certainly isn't going to get us towards solving the climate challenge, although it might be a bit player that in and of itself represents substantial industries.
Great, thanks.
Right.
Yeah. We have another question from Olawale, and this person asks, apart from the forest trees, there are some plant species which have huge potential for carbon removal from the atmosphere. Kindly comment on how much of this possibility for mitigation has been exploited at the international level.
In all of our work on bioenergy with carbon capture and storage, I am not a plant physiologist, but I worked with a lot of leading plant physiologists in that work. And what they would emphasize is that at the same time, there are intriguing features of species that would require less water or be able to grow higher. What we should recognize is that we've seen major yield increases in agriculture to date. We haven't seen massive increases in the efficiency of photosynthesis in the 2 billion years that Robisco has been on Earth. So in some ways, there are neat opportunities for breeding to help us in the space of bioenergy with carbon capture and storage, or just straight up use of plants to store carbon on the land, at the same time that we don't want to have outlandish expectations of a fundamental reworking as some sort of miracle that would solve the climate challenge right there.
Mm-hmm. Great. Thanks. Well, I think there's some wrap-up comments, so Will, I'll turn it back to you.
Oh, okay. Thank you so much. We're almost at the very end. I guess I'd make a very brief comment on direct air capture, because that was one of the questions also. Given relatively short shrift in the IPCC study, in my mind, too short a shrift, but some of the issues that are associated with direct air capture, which could have a very large potential sequestration potential, but some of the challenges include the energy requirements, which can be very high, costs, which are to some degree associated with energy requirements, though some argue those costs have come down substantially and will continue to come down substantially, and the need for, as is true with Becks and some of the other options, large amounts of storage for carbon dioxide. And so characterizing areas in which you can match storage with where you might site these facilities will be an issue, as issues of permanence. And with that, I'll leave it and see if there's comments from anybody else at the end.
My 2 cents ending point would be that 1.5 degrees Celsius represents real dangerous climate change, and the world as it is not on track. Carbon removal has a critical role, but we really need to be attentive to synergies and trade-offs in ensuring that climate responses build a better world.
I can just add my 2 cents on top of that. I fully agree, Katherine. I think it's important to look at all these options in a risk management framing. Where we're headed now, business as usual, we know is catastrophic. And each of these options that have been presented have their own trade-offs and risks as well, some that we know and some we don't know as yet. We also haven't talked about the Sustainable Development Goals. So on an international level, when all governments agreed in 2015 to support the Sustainable Development Goals, it's pretty clear from this report and from many, many others that there will be trade-offs in terms of land use or water or human rights issues or migration or go down the list. So we would just advocate for looking at each of these options, each of these measures in that more holistic framework and consider what kind of transboundary issues there might be and what kind of international governance may or may not currently be in place to address those. And if it's not, then where do we go from here?
Okay. Anything more from you, David?
No, I think you've covered it all.
Okay, so at this point, I'd like to close out the webinar by first of all thanking our speakers, Katherine Mach from Stanford University, Cynthia Scharf from the Carnegie Climate Geoengineering Governance Initiative, and David Morrow from the Institute for Carbon Removal Law and Policy. And I'd also like to thank all of the participants for joining us, as well as their excellent questions. And I hope you will join us as we continue invariably to discuss these issues in the future. So once again, thank you.